Okay, so we're going to look at some of these questions with, as I said, they still involve Pythagoras, but just a little bit more detailed. So here we can see in question 1, it says the cross-section of a water pipe is circular with a radius of 50 centimetres, as shown. The surface of the water has a width of 80 centimetres, and the depth of the water in the pipe D could be. So this bit here is the question. Okay, they want you to know. Now this was like the one we did yesterday, but they've put a little bit of wording to it, made it a scenario. So remember how we said this is the radius out there, that's 50 centimetres. So anywhere from the centre of the circle to the edge of the outer edge is the radius. So I can say down there to there is also 50 centimetres. So we know that down that way would be 50 centimetres. Now, they have given you what they called yesterday was a chord length. So this was like a chord across here, and they're saying that that's 80 centimetres. So if I just got half of that bit, what would that be? 40, good. So if I draw out this triangle up the top here, you can see I have the radius out here, 50. I've got the half of that, that's 40. Now what I'm going to do is I'm going to find this length here. So I'm going to call that X. Now can you see that X bit is here to here. Alright, so would you be happy to say if the radius is 50, if I minus X, would that equal the depth of the water? Yeah? Would that equal this depth? Yeah, it would. Alright, so we're just going to use Pythagoras up here with that little triangle there to work out what X is. So what side is 50? Well, if I've got the formula C squared equals A squared plus B squared, 50, good, is C. Doesn't matter which one I call for them. So I could write that out. So 50 squared equals X squared plus 40 squared. And then we can just use solve, can't we, on our calculator. How do we get solve again? Menu 3, 1. Good. And we can solve and we can get what X is. Okay, so we end up with X equaling 30. So therefore, I might say 50 minus 30 equals the depth, which is 20 metres. I think because it was measured in, centimetres, wasn't it? Sorry. So 20 centimetres equals the depth. Okay, for a square-based pyramid, sorry, I'm reading this one here. For a square-based pyramid, A, B, C, D, E. So when they label that, they're just labelling all the points or the corners of this pyramid are shown below. And the sides of the base of the pyramid, the base is 7 centimetres and the slant edge is 8 centimetres in length. The vertical height of this pyramid is closest to. So this is the question here, and what they want you to know is that is the height. We're trying to work out that height. So if you look, you know now, because we're doing Pythagoras, we need to get a right angle triangle. Now, if I find a right angle triangle with this using that height, I can use that and that slant. So what that would look like is I've got the H down here, the green goes across the bottom, and then I have the slant, which I know is 8 centimetres there. So I need to find, and I'll call it X, I need to find this as well, because Pythagoras I need to have only one unknown. So there is a way of working out that X. Now if from here to here is X, can I say, sorry, can I say here to here is also X? Yeah? Now if you look along the bottom, along this triangle here, that is also a right angle triangle. So where that's 7 centimeters too. So what I'll draw this one over here. So really the right angle triangle got 7 centimeters, 7 centimeters, and then you've got the green line that goes through. So where I've got X and X. So there's my right angle triangle. So I can find out X using Pythagoras. So if I look, this would be my C side, this would be A, and this would be B. And I don't even have to break it up. What I'll do is I'll say there's 2 X's there, so I'm going to say 2X, and I'm going to put it in brackets and square it. That's like the C, because there was 2 of them. And then I'm going to say equals 7 squared plus 7 squared. And then I can use the solve, comma X, and it will tell me what 1X is, which is what I want to know. So let's do that. So I get X to be, I'm just going to round up to 1 decimal to a whole. So it's approximately 5. It was 4.9. I was going to say approximately 5. Okay, so now I know that X is 5, and now I can use that over here on this one. So I know this is C, this is A, and this is B. So off I go, I write it out again, C squared equals H squared plus 5 squared, and we can solve again and find out what the height is closest to. Okay, so I get roughly it to be 6.2 centimeters. All right, so that one is 2 steps. To find what height it was, I had to do 2 problems pretty much, 2 Pythagoras problems. So this in an exam will probably be worth 2 marks, 2 processes. Maybe in your exam could be worth a bit more, but the process is a 2-mark thing. Okay, let's go. I'm not going to go through this one as such because the working out is there, but you have to see what you can use this bottom triangle down here to get. It's like what we did with the pyramid, so we can get this line across there, which we then can use for that triangle like that. All right, so it goes through the process for you. You can always just use solve at any point. So here, instead of maybe calling it DB, I might be calling it C for hypotenuse. I'd have C squared and I'd use solve, comma C, okay? So you don't have to do the manual way, just do it on your calculator. But I'm gonna move on and do actually this one down here, this example here. All right, so that we can do one together as such. All right, we have a cube in the diagram on the right, has side lengths of 5 centimeters, so I can see that there. The length of AC to 2 decimal places. So we want AC and 2 decimal places. Make sure you're highlighting that. So if I go over to my diagram, AC is along the floor there. So what I'm going to use is I'm going to use this right angle triangle there. So for question A, the triangle I've got is here's A and here's C, and I'm going out along the floor, and there's B and there's the right angle triangle, but I know these are 5 and they're 5. So if I go to find, this is what I want to find, so X, so I might call that's C, this is A, and this is B. So I can go X squared equals 5 squared plus 5 squared, and I'll do solve. And I'll work out what that is. Okay, now it's set to 2 decimal places, so I get 7.07. There's 2 decimal places. But they really asked me what AC is, so I should probably make a statement. AC is 7.07 centimeters. Okay, and then I'll put a box around the answer. All right, when we go over to do part B, what they want is AD. So they want this one up here. So I'm going to use that one. And I'm also going to use the side length here of the cube, which I know is 5 because they said it's a perfect cube. Okay, so if I draw out the triangle I need, I've got here D, C. I'm actually using C to A, and then I've got A to D. This is the question. Now we just worked out that AC was 7.07, and we know this is 5. So off I go. There's C, A, B. X squared equals 5 squared plus 7.07 squared. Solve, comma X. Okay, I got X to equal, it said 2 decimal places, so 8.66, and it's centimeters, but I really should call it what they called it, which was line AD. Now, in a right angle triangle, what's the largest side of a triangle? Hypotenuse. So when you're finding the hypotenuse, you should look that your answer was bigger than the other sides of your triangle. So what I'm saying there is 8.7 bigger than 5 and 7.7? It is, isn't it? So I know I must have roughly done it right, yeah? Sometimes that can trigger if you're doing something wrong. And same down here, 7's bigger than 5 and 5, isn't it? So that's a good way to check. You've got to work out ways to check your work in a different way so that you know you can pick up a mistake.